Okay, so this thingy right here is called the radical symbol. Remember, at the top it's the vinculum. This is the index. This is the radicand. The entire thing is called a radical. The entire thing is called a radical. And I had all these papers, and I don't know where my papers went. Great. Way to go, Blair. Now, do you see how it has a little star by the index?
Yeah, because I said it.
And then there's a star at the bottom. It says if the index is not written, it is automatically a what?
1.
Nope.
0.
Nope. A 2. Because remember how we start by calling these a square root?
Oh.
So if there's nothing in there, if I wrote this, we would know that means the square root of 4, right? So that's automatically a 2 if there's nothing in there. Now if I had a 3, that would be the cubed root of 4. And there's not a cubed root of 4. But we're going to talk about how to break this down in a minute. Any questions so far? Remember yesterday we talked about how to convert from one to the other. The exponent, which is the numerator, goes beside the x. And the index, which is the denominator, goes in the mullet. You guys remember that?
Wait, so you know how you said this in cubed root 4. Would they put it like that sometimes? Or it was
We're going to talk about how to break them down in just a minute. And what you do in that situation.
Can I go ahead and answer first problem?
What is it asking you?
Square root of 24.
Okay, so tell me what the index is, Cheney.
2.
And what is the radicand?
1.
What's the radicand? 24. All right, take a point. All right, Hufflepuff, can one of y'all please tell me what the index of the next one is? Okay, and what is the radicand? Take a point. All right, Gryffindor, can you tell me the index of the next one? And then can you tell me the radicand? Take a point. Beauxbatons, can you tell me... Also, Hannah, are you missing a light blue? Are you missing a pink? The pink's in the marker box. Here's your light blue. I didn't see you again yesterday to give it to you. I'm sorry. All right. So, Beauxbatons, back there in the back. Can you guys tell me what the index is? And can one of you tell me what the radicand is? Take a point. Good job. All right, Slytherin, can you guys tell me what the index is of the next one? Awesome. And what is the radicand?
512x squared.
Awesome. Any questions so far? So can y'all fill out the last 4 without me? Do it. Get super excited. Also, Grades and iNow are completely updated with everything. I'm real proud of myself. Are we done? Yes, I made it.
Would it be negative 162?
You tell me.
Talk about David.
Oh.
Well, could you look at me like I called you fat?
No, I wasn't looking at you like that. I was looking at you for the answer to the negative 162.
What if you, I think it'd be positive. I thought it said can
It would be 1 over 160.
You can't have negative what?
Negative. Oh.
We can't have negative what?
Exponent.
Exponents. Is that an exponent? No, that's not an exponent.
That's me.
That's not an exponent, babe. Not at all. Alright, so what's the index on the next one? Take a point. Alright, what's the radigan? Awesome.
That's a point.
That's a point for us.
No. What's the index of this one? Radican? I don't even know what you're saying. Alright, what's the index on this guy? Radican?
98.
Hey. Three.
Three.
Look at us go. Okay, so what we're going to learn how today, potatoes. I'm going to learn how to talk. What we are going to learn how to do today. I did it. Alright, we are going to learn how to break these down. We're going to learn how to simplify radicals. So what we're going to do first is I'm going to give each of you an index card, and you're going to list the perfect squares from 1 to 20. Who in here knows what a perfect square is?
Square root where it like goes in it without being a decimal.
Yeah.
Yes, when you take the square root with and you don't get a decimal, take a point. Is 3 a perfect square?
No.
No. What about 5?
No.
What about 8?
Yes.
No.
No, it's not.
Oh, it's all in.
So perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 1, 156, 2,
Potato.
something. So we're going to list them from 1 to 20 on an index card so that you can have it in your notes. Does everybody understand?
Yes.
You can also keep it out on your desk. Do we want big index cards, or are you okay with smaller ones? Yes.
You like running for that too.
I didn't hit pause. Can somebody hit pause on the laptop for me, please? Alright, nobody jump all at once. 20 index cards? No, you picked. Why would I give you 20 index cards? I'm not made of money. At the top of your note card, I want you to write perfect squares. An index card with chevron. I don't understand what's happening. We don't know what card this is. We don't know what initials are. It's really nice. Is that what you said? Thank you. You had the option to take one of these. Sorry, guys.
I want that one.
That one?
Just that one of them colors.
One of them colors?
Like the one with
Okay, so what we're going to do is we're going to take one colored marker, and I would get a skinny one so you can write, and we're going to just write the numbers 1 through 20. Okay? 1, 2, 3, 4, 6, 7, 8. And leave space in between your columns. I handed you one. We're going to go to 24, just because, or you can go to however many makes yours even. How about that? Because I'm a weirdo and can't handle it if it's not even. Okay. You can go over 24, you can go to however many makes yours even, whatever you want to do.
What?
Come on, home skillet, pick up index card.
I did another one. I messed up.
Nope. I'm going to slap your forehead again. Alright, so what we're going to do now in our other color is we're going to square each of these numbers. My perfect squares are going to be in purple. So a perfect square is when you square your counting numbers. So 1 squared is what?
1.
Okay, 2 squared is? Your pre-AP, what's 2 squared?
4.
3 squared.
9.
4 squared.
16.
5 squared.
36.
Oh, I see how you do this now.
16.
Wait, someone for a second.
4. 9 squared.
81. 100. 121. 144. I don't know.
Okay, well, what's 13 times 13? You can also get a calculator.
164.
3 times 3 is 169. For using our calculator. 14 squared.
196.
That's the one I messed up on. 15 squared. 16 squared. That's 256, right? Look at me go. 17 squared is 289. 18 squared is 324. Yes. 19 squared is, I don't know that one.
361.
Thank you. What do you think 20 squared is? 400. Take a point. 21 squared.
446.
That is not.
What?
441.
22?
484.
You can't stand what kind of teachers?
I said I can't say that to a teacher to say it's not okay.
Okay. 23 squared
529.
and 24.
576.
Thank you for your help. Take a point. So I at least want you to know 1 through 20. But what we're going to do with these is to break down and simplify a radical. You find the biggest perfect square that goes into a number. And remember your factor trees? Some of us? Kind of?
I don't remember that one.
Okay. So if I give you 30. Okay? Is there a perfect square that goes into 30? If I said the square root of 30.
15. No. No, that's
Purples. That's Thunder. We're fine. It's Thor. He's coming to visit. Thor. From Avengers.
No, there's none.
He's a Norse god. God of thunder.
God always plays bowling.
Alright. Oh my god, kill me.
No, nothing goes in the.
Alright, what about 24?
No.
What perfect square goes into 24?
12.
Y'all, does 4 go into 24?
Yeah.
Okay. So 4 times what gives you 24?
6.
Okay. Is there a perfect square that goes into 6?
3.
Y'all, perfect squares are the purple. Is there a purple number that goes into 6? No.
It's 2 for 4.
So it would be 2 root 6. What's the square root of 4?
Oh.
Alright, somebody's alive. Square root of 4 is 2. Once you take the square root, you take it to the outside. You leave 6 underneath. Thank you.
What? Chills.
I was like a drug.
You forgot to buy drugs. Nobody brings
At school?
They don't say thank you.
Oh, yeah, that's true. I'm just saying.
They just take you.
How do you know?
Huh?
It's recording. Stop.
Yeah, hey, wait.
Stop. So what we're going to do now is on the back of 45C, we're going to write down, we're going to start with the ones that are just square roots, and then we're going to move to cubed and 6s and 4s. We're going to write these on the back. So the first one is the square root of, we're going to write number 1. This is 45D. We're taking the square root of 24, and we're breaking these down.
It's 2 6.
I can't do that.
2 6.
Yes, keep that out. We're going to need it.
I can't do that. I messed up.
All right, so then remember, we broke this down into 4 times 6. So that's the same thing as the square root of 4 times 6. The square root of 4 is 2, so it's 2 root 6.
I don't.
So,
I don't.
this happens.
Yes.
What happens to
We took the square root of it.
Okay, so
So what that means is we broke 4 down into 2 times 2. Okay? So square root means you need 2 of the same number. So we have 2 of the same number, right? You take out one of them, move it to the outside. That's it. That's all square root means.
She's saying 4 is the square root of 16.
Square root of 6.
4?
4 is the square root of 16? Is that what you're saying? Yes. I'm sorry, I didn't understand what you were saying. You're just kind of muttering it. Yes, Dalen.
okay, so we need to do every time like find the square root of those two numbers and like interface.
Yes.
Okay, if it can't go into other,
Stop, guys. I can't hear him.
if it don't have like a square root,
It stays under the radical.
so then we just find the two numbers.
Yes.
Okay.
Okay. All right. Number 2. Are you guys ready? The square root of 512x squared. So we need the biggest perfect square. And remember, on my card, that's the purple. On your card, it's whatever color you did for your second column.
400.
So you think 400 goes into 512? Do 5. What? Baby, 21 is not a perfect square.
You talking about four?
The biggest purple number, okay? So let's start with a big purple number. A big one, guys. A big purple number.
5.
Purple number. Oh my gosh. What? I don't even know what y'all are saying. Baby, 576 does not go into 512. Okay, so please take your calculators and do 512 divided by 484. Does that go in there evenly?
Let's see what going there evenly.
Right, it has to go in 16. Okay, so let's do 512 divided by 16. You get 32. But is there a perfect square that goes into 32? So we need something bigger than 16.
A bigger purple number?
Yes, a bigger purple number. So I'm going to do 512 divided by 64 and see what I get. Man! But there's still a purple number that goes into 8, so I'm going to go a little bigger.
It's not 90.
That's what I'm talking about. Alright, so it's 256. 512 divided by 256 is 2. Now, this is kind of a guessing game, but you want to have the biggest. So don't start with the small purple numbers. Go with the biggest purple. So that's 256 times 2. This is what we broke that down by. Now, what two numbers multiply by, or what number multiplies by itself to give us 256?
16.
And if you don't know, go to your purple, look to the left. So it's 16 times 16. Is everybody with me so far?
That'd be 40.
No, don't break it down further. Okay, so what we did was we found the biggest perfect square that went into 512.
Wait, I got a question. Are all these numbers able to go to 5?
No.
The height? I don't know.
You find the biggest.
But what if none of them go into the number?
None of your purple numbers go into it, then you leave it.
Why did you start with 256?
Because that's the biggest. I got 256 times 2.
Oh, you trying to get 2?
No.
That's a bit intimate, like, you're below this.
I want the biggest perfect square that goes into it and gives me the lowest output number. Over here, our biggest one was 4 because we got 6 out. There's not two numbers that are the same that multiply together and give you 6, right? If we chose 64, okay? And I did 512 divided by 64. Don't write this down, just watch. I would have 64 and 8. Is there a perfect square that also goes into 8?
Yes. No.
Are y'all serious? 4 goes into 8. 4 is a perfect square.
Oh, perfect.
4 times 2 is 8.
But you said
I don't get what we trying to do.
Okay, guys, do you see this purple column?
Yeah.
I'm using the purple column to divide into my number. I'm only using the purple column. These are my perfect squares. I'm only using those. Ma'am?
Clicking the perfect squares and the numbers of it.
Yes, I'm only using perfect squares. So the reason I want my biggest is because I don't want to have to break this guy down. If I broke this down, it would be 8 times 8. And then I would have to break him down, and it would be 2 times 2. So you're trying to break down using the biggest perfect square. Because then you're going to take the square root of this. So if I take the square root of this, I'm going to get 16. Because 16 times 16 gives me this. I have 2 of the same number. Since it's a square, you want 2 of the same number. If I break it down over here, how many times do I have 2 of the same number? Twice. If I took the square root of this, I would have 8. If I took the square root of this, I would have 2. What's 8 times 2?
Would that be a shorter version of it?
Yes, that's why we're doing the biggest.
But can't we just do the smallest and...
Then you have to break it down more. If you do the smaller number, you have to break it down more times, and you run the risk of not breaking it down completely. Because you guys just told me that there's not a perfect square that goes into 8. Y'all just said that. And there is.
Well, you said earlier that a square root of 2 of the same numbers multiplied to get.
That's it.
But I'm talking like right there, 8, there's no 2 numbers anymore. But like there is, but they're not the same.
4 times 2, right?
That's not the same.
But you can break down 4. 4 is a perfect square. And you break it down into 2 times 2. Yes.
On the first one, how did you get the 2, 6?
Right here?
Yes.
2 root 6, because what's the square root of 4? 2. So, once you get 2 of the same number, okay, you take the square root of it, because the square root means 2. So we need 2 of the same number. We take one of them and move it to the outside. The other disappears. We're still not understanding. Okay. What is, I need this. What is the square root of 25? How do you know that?
That's easy.
I'm not done. And that gives you 5. What if I said that I'm looking for the square root of 75? Is 75 a perfect square? What is the biggest perfect square that goes into 75? 25. It would be 25 times what? 3. Now, we do not have 2 of the same number, but we have a perfect square. What does this break down into? 5 times 5, right? What is, and then, so what's the square root of 25? You just told me. What's the square root of 25? What's left out down here? It stays under the radical. Okay, now wait. What's the square root of 256?
16.
Okay. Now what if I said the square root of 256 times 2? Can we take the square root of 2? No, it's not a perfect square. What's the square root of 256? What's left under the radical? We're not there yet.
So you take the perfect square.
You take the perfect square every time. And that's why I want you to have the biggest perfect square. Because if we had 64 times 8, you guys are going to say, well, there's my perfect square. It's 8 root 8. But 8 has a perfect square in it. What is it? 4. So you would have 4 times 2. 4 is now our perfect square, right? What's the square root of 4? So we would bring it to the outside. It would be 8 times 2, and we would leave this guy under there. What's 8 times 2? Yes. So take the biggest one. Does everybody understand? At least a little more. It's okay if you're not perfect on it yet. That's why we're practicing. Yes, no, maybe. Okay. I'm okay with a maybe. Alright, so this, I have 16 times 16, right? I'm going to take this out, and I'm have my 2 under there. Now, we have an x squared. How many x's does that mean we have? So if we take the square root of that, how many x's are we going to have on the outside? So it's 16x times the square root of 2. Because this is 2 x's. So when you have 2 of the same, you bring 1 to the outside. Does everybody understand? That's okay. You see, x squared can be broken down into x times x, right? Okay? That's like having...
Miss Asbury.
Yes.
Hey, was Kimberly Torres in second period this morning?
No, ma'am.
Thank you.
So you have 2 of these, right? And you see how we had 2 16s? We brought it to the outside. Same thing. All right, we're ready for the next one.
What is this called?
Breaking down radicals. Simplifying radicals. All right, we are just going to do 98k. The square root of 98k. We're going to call this number 3. All right, we need the biggest perfect square that goes into 98. I'm not finding one. Are you guys? Oh, I did. 49.
16 times.
Did you do six? What'd you get when you did 16? But it was 6.125.
Yeah,
I got 16 times 6.
But we're looking for 98.
Oh.
All right, so I got 49 and what? 2. Okay? Now, what can 49 be broken down into? 7 and 7, right? So what's going to become on the outside of my radical? What stays under it?
2K.
2k. Why did we not break down this k, but we did the x squared?
Wasn't 2 of them.
There's not 2 of them. There's just 1. Fantastic.
It was 1.
We're going to talk about that tomorrow. All right, homework.
Okay, we got 1.
Where do we put our perfect squares?
You need to keep that because you need to be able to do your homework.
Go on our page.
You can attach it to there somewhere. You can glue it, staple it, just keep it in your pocket. All right, homework tonight is, I'm going to put it on Google Classroom so that you guys can go. It'll be at the end of the video, okay? And I'll take a picture. I hope you guys have a great day. Make good choices. Be good people.